Instantiating arrays is a lot like instantiating any other object. So I'll first note that arrays are also objects. So what's an object? Well, that's like a planet or a walrus or a dog or whatever else, but it also includes arrays. And as we've seen, objects are usually instantiated using the new keyword. So I might say planet p equals new planet, yada, yada, yada. Or I could say int array x equals new int, and then use this syntax that we saw in homework 0. Now in the previous lecture, we broke down declaration, instantiation, and assignment into separate steps. So let's just do that again in the context of arrays and make sure that everything all makes sense. So when I say int array a, this is a declaration. What that does is it creates a box which has 64 bits in size, which can store the address of an int array and nothing else. Even though technically int arrays and planets and walruses and so forth, all of those variables store 64-bit addresses, the compiler will only let us store an address of an int array in this box. Now at this point, there is no actual object, so we've only declared a variable. Next up, there's instantiation. So when I say new int braces 0129554, that will instantiate a new object. That is, it will create 5 boxes, each of size 32. It'll put 0, 1, 2, 95, and 4 in those boxes respectively. And then the new command will return the address of this object. Now at this point, I'll say the object is anonymous in the sense that there's no name for it, right? We haven't assigned it to a variable. The address is shouted by new, but it falls on deaf ears. And so while this object is created, it is immediately gone, or just not usable. So I should mention very briefly that an array is not actually literally only 5 times 32 bits. There's a little bit of additional overhead not shown here, but not really a big deal in our class. And then often we will do declaration, instantiation, and assignment all in one step. So here it is. The declaration part of this line, it creates a 64-bit box for storing an address. New int creates this int array. And then finally, the equal sign takes the address shouted by new, and this time, rather than falling on deaf ears and not ever being known, it is stored in the a variable. So just to finish out this little section, I figured I'd mention the fact that instantiated objects, that is planets, arrays, whatever else, can be lost. So in other words, let's say a points at this object right here, and it's the only copy. It's the only copy of the address, this 64-bit box here. In that case, if we were to say a equals new whatever else, right? So a points at a new object, then we no longer have this address stored anywhere. And therefore, there's no way we can ever get that object back. That's not a bad thing. I mean, there are cases, as we'll see pretty soon, when we start building lists, where we do actually want to lose references to things. But just a note, we lose an address, that object is lost, and will be consumed by the garbage collector.